What is saytzefs product? What is saytzefs product? Highly substituted alkene is called as saytzefs product. What is Hofman's product? Less substituted alkene. Note down one word. In generally, saytzefs product is major one. In generally, in elimination reaction, in generally, which is major one? Saytzefs product is major one. Saytzefs product, right? So in generally, which alkene is major one? The alkene with more number of alpha hydrogens is the major one, right? Our heading is writing major product or writing number of alkenes. Let us take one simple example and let us decide which is a major alkene and which is a minor, which is major product and which is minor product. This is question coming area. Okay, look at this. Coming to the first example. What is its name? Anybody? Can you give its IUPAC name, Aisha? What is its IUPAC name, Aisha? What is its IUPAC name? Vaishnavi, what is its IUPAC name? Two-chlorobutane. See, I am writing the products here. I'll tell you how I'll get the two products. Right. Which is having more number of alpha hydrogens? Second one or first one? Second one or first one? All of you look at this. Put the double bond in a box. Select the carbon which is next to that box as alpha carbon and take hydrogens on that carbon only. Underlined carbon is alpha carbon, which is having how many hydrogens? 2 hydrogens. Which is having 2 alpha hydrogens only. Clear? And the second one is having how many? Put the double bond in a box. This is alpha carbon, this is also alpha carbon. This is having 3 alpha hydrogens, this is having 3. Total how many? 6 alpha hydrogens are present. So the one with more number of alpha hydrogens is said to be saytzefs and that will be the major product. The one which is having more number of alpha hydrogens is said to be saytzefs product. Saytzefs product. And this is major one. In generally I am saying. In generally. So just count number of alpha hydrogens. Clear? So what is the major product when 2-chlorobutane is subjected to dehydrohalogenation? Alcoholic K which is dehydrohalogenation. Removes hydrogen and halogen. What is the major product? 2-butene is the major product. Let us see how we will get these two products. Okay. See, I am writing. Yeah. I am going to explain that only. See. I am writing this 2-chlorobutane like this. CH2H. I am writing one hydrogen down. Okay. Remove HCl from these two. Okay. Here you will get double bond. Online students, are you getting? Once look at this, Aisha. Carbon and chlorine, carbon and hydrogen. Okay, remove HCl like this. So where you will get double bond? At this. So one butene, one butene, one butene. This is one possibility, right? Minus HCl, remove that. Here. Now draw this in another format. Now take this hydrogen. See, you can remove hydrogen which is present on the beta carbon. Actually this is alpha carbon. Why halogen attached carbon is alpha carbon? Which hydrogen you have to remove? Beta. You can remove this beta hydrogen or this beta hydrogen. Clear? You can remove any beta hydrogen. But that product stability depends upon the hyperconjugation. Clear? How many beta hydrogens you have, you can remove that many beta hydrogens. Clear? But later we will select a stable one. That is a different case. Now what I am writing next, CH3 CHCl, this hydrogen, this beta hydrogen down. Okay, now remove H and Cl. Where you will get double bond? Here in the middle you will get double bond. Clear? This is alpha, this is beta. So you remove this beta hydrogen and the chlorine. Now you will get 2 butene. Clear? Did you get now? Adiba. So which is major one? Second one is the major one. Why? It is stable, more number of alpha hydrogens, saytzefs product is the major one. No doubt, na? Clear? Right. In 99.9% cases, which is major one? Saytzefs or Hofman cell? Saytzefs only. No doubt in that? Clear? No doubt? Right. Next. Vaishnavi, are you following? Vaishnavi and Aisha. Both of you. See this example. Next one. Can you give major product for this? Alcoholic KOH. I wrote the product. You tell me which is major one and which is saytzefs product. I'll tell you how I got these two products. I'll tell you. First of all, you tell me which is major product, which is saytzefs. Online students. First one, how many alpha hydrogens it is having? How many alpha? First to locate. This is alpha, this is alpha, this is alpha. 3 alpha positions, right? Here how many hydrogens are there? 2. Here how many hydrogens will be there? 2. Here how many? 3. So total we have 7 alpha hydrogens. Clear? Now in this case, this is alpha, this is alpha. Here 2 hydrogens we have, here 2 hydrogens we have. Total 4 alpha hydrogens only. If more is the number of alpha hydrogens, that is said to be saytzefs product and a major product. This is saytzefs. Saytzefs product and major. I'll tell you how we will get these two. Look at this. Have you finished this? Have you completed this? See mechanism for that. I took this one only. No? C. Cl. See, this is alpha. This is alpha. So I have to remove hydrogen from the beta. See, I have how many beta positions? These two are same. Okay, beta, beta. I am writing beta 1 because these two are same. So beta 2. So I have to remove hydrogen from the beta carbon. This is alpha carbon. Why this is called alpha? Halogen attached carbon is alpha carbon. Halogen attached is alpha carbon. So I am writing beta hydrogen separately like this. Look at this. Beta hydrogen. I am removing HCl like this. Minus HCl. Then what I will get? Clear? This is one possibility, right? I am giving mechanism for the previous reaction. Next, another one. How I got another product? See, look at this, all of you. Here, this line represent methyl only, na? Look at this. Methyl only, na? Can I write the methyl like this? Once look at this, all of you, back. This line represent methyl. Here you have to imagine methyl. I wrote that only. See, methyl. Methyl is writing as CH2H. Here Cl is there, no? Cl. Look at this. This Cl just I wrote horizontally. Okay. Now remove these two. Here you will get double bond. Okay. This can be represented like this. Sorry. Alcohol. We are removing HCl. You are adding alcoholic OH. What is the role of alcoholic OH? It removes. We are doing elimination. We are removing H and Cl. For that we have to use one reagent. What is that reagent? Alcoholic OH. I have given the mechanism also, right? Aisha, tell me, in generally what is the major product? In generally what is the major product? Saytzefs, right? No doubt. Adiba, correct only, no? In generally, what is the major product? Saytzefs. Now see, very important for final NEET also. In some cases, Hofman's product will predominate. In some cases, Hofman's product will predominate. What are that some cases? Note down, this is my expected question if they give questions from the elimination, right? Otherwise, next exam also you will get, or in the unit test also you will get in the upcoming unit test. But very important. Clear? Note down, put star mark for this point. I already given, na? Here. Already mentioned major product, Saytzefs product. For this I explained the mechanism, right? Right, note down only 2 to 3 points are there, right? In the following cases, note down, in the following cases, Hofman's product will predominate. Hofman's product will predominate. Most important point. In the following cases, Hofman's product will predominate. See, 90% of the students, due to lack of concepts, suffering now. Clear? They are not getting the marks in the GTs also. Clear? Because of improper learning of the concepts. Clear? So for organic you have to go systematically. You should know about the rules, principles, concept, everything. Clear? Now present online is going in your college. You tell me, since you are taking the tuition, so you can understand what is happening in this SN1 and E1. So you can know about everything. But those which are not having minimum awareness also, they completely depend on the college also. Imagine their situation. The program will go like this only. After starting of the colleges, they won't get the marks in the half-line test. They don't know also even where they are lagging. They don't know. Clear? So what I am saying to you, you are listening. Okay. What is my suggestion? After completion of the class, do practice. Clear? Otherwise, there is no difference between you and other students also. Clear? Revision is very, very important. Listening and preparation and presentation also. Presentation in the sense writing exams. Okay, these three are very important. Right, in the following cases, Hofman's product will predominate. They will give questions based on this only. What are the following cases? Case 1. Case 1. When poor living groups are present. When poor living groups are present, most important in elimination. When poor living groups are present, what are poor living groups? Example, fluorine is a poor living group, NH4 positive is a poor living group, and generally fluorine will come mostly. Okay, fluorine will come. Iodine is a good living group. Correct only, na? Fluorine is a poor living group. Case 1. Is there any doubt in the? I will give the examples. Okay, with the examples we will discuss. Then you will get more clarity. Right. You tell me, when fluorine is present, you will get Hofman product as the major product. Because when poor living group is present, then Hofman product will predominate. Otherwise, in generally, say saytzefs only. If you do not get any condition, then saytzefs is the major. But when you get the condition, when they mentioned fluorine in the reagent on the reactant side, then be careful. Right. Case 2. When bulky base is present, very valid point. When bulky base is present, in that case also Hofman's product will predominate. When bulky base is present, in that case also Hofman's product will predominate. You have only one bulky base, very easy to remember. See that bulky base, you know already, tertiary butoxide, O negative K plus, or it can be represented like this. Okay, or it can be represented T butoxide, tertiary butoxide. The bulky base, when bulky base is given, then also you will get a Hofman's product. Completed? Aisha and Adiba. Aisha? Yeah. Now let us take one example. You tell me about living ability. Fluorine is a good living group or poor living group? Poor living group. First of all, write two products which is having more number of alpha hydrogens. Tell me. First write number of alpha hydrogens. This is alpha carbon, right? 2 hydrogens are there. Here 3 and here 3. So total how many? 6. Clear? Which is Hofman's and which is saytzefs? This is saytzefs, because It is having more number of alpha hydrogens. It is called Hofman's. In generally, which is major? 99.9% cases saytzefs is major. But in this case, Hofman's product is the major product. You no need to search for the reason. Clear? Right? Reason will not come in the exam. What will come? Select the major product and minor product will come. Clear? If fluorine is not there, I will show the difference here only, then you can understand very easily. Adiba, for you? Is it okay, everything? In this case, see, chlorine is a good leaving group, right? In this case, what will be the major one? This will be the major one. See, reverse. Got it? Why? Because chlorine is a good leaving group. Here, fluorine is a poor leaving group. Did you identify the difference? Write the product for this. Write major product. Try this. Write major product for this. Look at this. See the major product. This will be the major product. This will be the minor product. Right? What is the first case? When poor leaving group is present. Case 2. When bulky base is present. I already given. Let us discuss example. When bulky base is present. When bulky base is present. See. Here we do not take poor or weak, nothing. We are not saying type of product on the basis of poor leaving group, weak leaving group. Whatever it may be, whether it is poor or weak or anything. When you take bulky base, tertiary butoxide, CH3 taken thrice CO minus and K, or it may be represented like this also. Right, in this case, also this will be the major Hofman's product. saytzefs product is minor. CV. Elimination via conjugate base mechanism. Elimination via conjugate base mechanism. Elimination via conjugate base mechanism. Very easy to identify, and this is very important point. Which alkyl halides undergo elimination via conjugate base? Or carbene ion, formation of carbene ion, conjugate base or carbene ion. Which of the following alkyl halide undergo elimination via conjugate base mechanism or via formation of carbene ion? See, the worthy point, the alkyl halide having strong minus I or minus M groups in beta position undergo elimination via CB, conjugate base mechanism. Elimination via conjugate base mechanism. See, in generally In weekends, this type of questions will come, like basic rule, basic condition questions. Clear? Which of the following alkyl halide undergo E1CB? Clear? So for you also, I'm expecting these type of questions. First of all, let us see example. CH2F, or I'll take this one. Sorry. Look at this. This is the best example. Once give the positions here. Alpha position. Halogen attached carbon is alpha carbon. Next carbon is beta. On beta, strong minus A is there or not? So what is the statement? The alkyl halide having strong minus I or minus M groups in beta position undergo elimination via conjugate base. You have to check like this. Alpha carbon is halogen attached carbon. Next carbon is beta carbon. If more is the number of minus I groups, more will be the rate, reaction rate. For example, look at this. In which more minus I groups are there? In beta, more minus I groups are there. So its rate is more. Here only one minus I group is there. Its rate is less. Clear? Let us see the mechanism. Okay, then I'll close. If anything is there, just send the message, or we will do one small discussion. See the mechanism. CH2NO2, CH2Cl, use rise 2. I am taking base alcoholic KOH. This is the product. Okay, see the stepwise mechanism. First step. I am writing one hydrogen separately at this carbon. This is NO2, CH2Cl. Okay, what I am doing? Online students, I am writing here CH2 is there, na? I am writing one hydrogen up. Can I write like that? Yes. OH minus from the alcoholic OH. It will capture this proton, and leaving the negative charge or bond there only. See this bond, pink color bond will shift it to carbon as a negative charge, because OH minus is capturing only hydrogen without a bond. Then that bond will shift to carbon. Clear? Leads to formation of carbon ion via conjugate base. Carbon ion or conjugate base. What is the condition, you tell me? What is the condition when elimination via conjugate base takes place? When strong minus A is present in beta. Why? What is the reason? Tell me. Carbon ions are stabilized by which groups? Plus I groups or minus I groups? Minus I. That is the reason. Clear? That is the reason. Carbon ions are stabilized by minus I. Here carbon ion is formed now, so that will be stabilized by this NO2 minus I group. That is the reason. That's why I mentioned. Right? This is conjugate base or carbon ion. Conjugate base or carbon ion. Via conjugate base. I mentioned now via conjugate base. Conjugate base is formed. Right? Next. Conjugate base nothing but the compound which is formed after elimination of H plus. See here H plus is going. The negative part formed after elimination of H plus is called conjugate base. Via conjugate base. Elimination via conjugate base. If you remove H plus from any acid, you will get negative species. That negative species is called as conjugate base. Okay? Right. Step 1 is over. Next, look at this step 2. I am taking this as easily. Look at this step carefully, all of you. I am shifting this negative charge in between these two. Okay, at that time Cl will leaves. Here H plus is left, right? Here Cl minus. So HCl. Finally, elimination is taking place or not? HCl. Right? So this negative charge will shift like this. Then this bond will go like this. Cl will go along with bond as Cl negative. In the middle, we will get a double bond.